We all know that the cloud is the new center of gravity, but it is a very complex place with thousands, frankly, millions of applications running, many using sensitive data. How can this be managed effectively? We'll talk about that on this episode of Future Proof.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Yours truly, Eric Kavanaugh here. Very excited for another show. We're going to talk about a pretty big topic, folks. We're going to talk about the cloud. What is the key to the cloud? A single pane of glass. That's what we'll talk about. We've got Nong Lee from Okera and Titus Kurik from Canonical on the line. Titus calling all the way in from Poland, so he's working late. I'm sure it's not the first time he's worked late in his career, but we're going to talk about how with discipline and technologies, companies can manage cloud and really leverage the power of cloud, because cloud is the new center of gravity, first and foremost. I think that on-prem data centers are not going away anytime soon. There's going to be a very long tail to on-prem data centers, but the cloud is clearly the center of gravity. The cloud is where everyone's attention is focused on the dev side. We're trying to create solutions that are cloud native these days, meaning you can pull it out of one cloud, put it into another cloud. That's the ideal scenario. It's not that easy to do unless you get it just right. We'll talk about that. We'll talk about things like security, but really just being able to manage and understand and provision resources as you need to leverage the power of cloud. So let's dive right in. I'll bring Nong Lee in first from Okera. Nong, tell us a bit about yourself and what you're doing to facilitate the management of cloud through a single pane of glass.
Awesome. And hello, everybody. It's great to be here. So I'm Nong. I'm one of the founders and CTO of Okera. We've been in business about 6 years ago, and our heritage is in a lot of the Hadoop infrastructure from a decade ago and sort of the evolution since. Our focus is around data security and data governance and being able to do policy management at scale for large enterprises, right? I think people, large and small organizations of different sizes and industries increasingly care about how to control access to data, making sure that PII is redacted and anonymized and all of those kind of things. And our platform is designed to be able to do that very effectively. Obviously, yes, totally agree with you. Cloud is the sort of where all the attention is and where new investments are. And certainly most of our customers are asking for help on how do we help them solve these kind of data security problems as they modernize their infrastructure in the cloud.
Yeah, and Okera has such fascinating technology. I'll kind of explain how I understand it works, and correct me if I'm wrong. But Okera is trying to provide for what we might call responsible analytics. And what I mean by that is if you're a data science team, if you're a business analyst, and you're trying to wrap your head around a particular topic, a particular domain, what do you want to do? You're going to be doing queries, and you're going to do queries of various systems, databases, for example, relational databases, obviously data lakes sometimes. Well, to manage access for solutions like that, traditionally you had to manage it at the database level, for example, or possibly at the consumption layer, meaning you have to log in, give your credentials. But when you think about the sprawl of information sources out there, the excitement around cloud data warehousing, for example, with big companies like Snowflake changing the game. Of course, Amazon has its own Redshift. When you think about the complexity, it's pretty quick that you realize there's no way you're going to be able to manage that environment. You need dynamic policy enforcement where you can put in place policies that say someone with this level of seniority who is in this particular department and is working on these projects should have access to any data that is related to that particular person's work, right? Which is dynamic in nature, meaning it's not just a simple rules-based system, and it's not to where you're just saying, okay, these 847 people have access to that database. I mean, that's a recipe for absolute disaster from just a basic management perspective. Is that about right, Noah?
Yeah, you really nailed it. So yeah, absolutely. So that minimizing complexity and being able to make these decisions much more dynamically than we have in the past is sort of core to our technology, right? It's that, look, it should be automatic that, a user joins a team, they automatically should be able to see the data that that team is entitled to without a DBA or anybody having to reconfigure things and so on and so forth. Right? You brought up kind of the 847 users, but on the flip side, that's traditionally been hard is, and then we've hard coded exactly which columns and which tables and which data sets he or she can access. And then of course, as things are moving faster, as enterprises adopt the cloud, that data ends up in many, many more places, or like similar content ends up in many, many places. So you're really getting hurt when you have to sort of hard code and do this big change management step just to get users access to data.
Yeah, and that's the term, right? Hard coded. It reminds me of scripting, right? In the old days, in the early days of data management, and this still happens today, right? There are these arcs of innovation that span years and different technologies. But you think about how this has been done over many years. You would do custom code, little scripts to pull data from here and send it over there, little ETL scripts that you would write. Well, that works fine in the beginning, but once the environment scales, that doesn't work fine at all, especially if the person who wrote the script leaves and now you don't even know who wrote it, where it is, what it does, what it did before. I mean, it's just a complete nightmare for someone coming into that organization green. And then you add in something like the Great Resignation, where all these people are leaving their old jobs, and with them goes all that head knowledge. So those kinds of things, I mean, I remember having a conversation with a DBA for, I think, a government agency in Texas like 20 years ago, right? And this girl was joking with me. She goes, "Oh yeah, I put everything in the database and in stored procedures, and that way they can never fire me." I mean, she came right out and said that, like, I can't be fired because they don't know what I've done. And yeah, she's not the only person to do that, but what a clarion call to get clarity of policy and manage this whole operation in a completely different way, right, Noam?
Yeah, absolutely. And we see that a lot, right? We have sort of our customers will have built up policies over probably a decade, right? With different rules, different people. And sort of our thesis is policy complexity scales exponentially, right? If you have twice as many rules in your system to think about, it's way more than twice as hard to be able to deal with it. And you can imagine sort of the buildup over time. So again, kind of the core tenets of what we do is let's dramatically shrink that, right? We're not talking about, half as many, we're talking about, 10% as much or 1% as much, right? 100x reduction. And we really think that's kind of the platform you need to build on. I mean, I think in the context of sort of the cloud and what we see in enterprises, and I think what everybody sees is the sort of heartbeat of technology adoption has just gone way up, right? The cloud makes it easy for you to spin up new infrastructure. It makes it easy for you to try new services and products. And if you compare that to maybe even just 10 years ago, where you have, data center provisioning and hardware buying cycles, now it's just completely different, right?
It's just crazy.
Because the whole thing takes less time, it's now pretty painful if you spend 3 to 6 months provisioning data, because now that's the long pull by a lot. Whereas before, maybe if you had 2-year infrastructure life cycles, 3 months doesn't feel so bad. But right now, this is really, really important. And that's what's driving people to look at things like this.
And you know what? That's a great point. And what you're reminding me about is the evolution of DevOps and then data ops, right? So data ops learned a whole lot from the DevOps space. And just to explain to our audience, developer operations, basically, where developers started working directly with the operations people to solve problems. A lot of times in the front end, like on a website, but also in the back end in procurement or sourcing or whatever the case may be, you had developers just working directly with the business. Now, it was very interesting because before that, you had this real divide between the business on one side and the IT people on the other. And there weren't too many people in the business world who understood enough about the IT stuff to reasonably and effectively manage those operations. And so you had the IT people trying as best they could. And I'm not saying that they were not doing what they could do, but they were trying, but still it's very difficult. Well, now you have DevOps. And I think what happened is it took off so fast. They started getting such good work done, but then it's a question of governance and knowing what had been done and documenting what had been done and being able to explain to an auditor or even to an executive. That kind of went out the window for a while. And the same thing happened. And that's why I think we had data ops come along to solve for that problem. It's like, okay, like who's managing the data? Make sure we have an environment where we can see that there's a whole workflow around this. We can get the lineage, we can get all the governance that we want. And I think that's sort of part and parcel to getting us where we are today, which to your point is amazing that you can just spin up all these resources in the cloud, but unless you have data ops, unless you have some governance structure, you can get great stuff done, but you're running the risk of just running afoul of policies everywhere you go, right, Nong?
Yeah, absolutely. And it's just so incredible to see how much faster we can move today than again, just even say 10 years ago. But you're right. I think usually, when we think about our business, we've always fundamentally wanted to balance utility, right? People being able to get access data to do their job quickly, not just being a sort of something that slows you down, and then security and responsibility, right? And we think the right tooling lets you do both. I think in your go fast, then maybe we're going, we've got to have some more controls as, seatbelts don't slow you down, right? They let you drive faster on average.
That's right.
That's very much sort of how we think about it.
Yeah, I love that analogy too. Seatbelts don't slow you down, they protect you. And one really cool thing about the cloud is that, and I'd be curious to hear your thoughts on this. We were talking before the show about service-oriented architecture and open source technology and how the confluence of those two practices really revolutionized enterprise software development. I mean, absolutely revolutionized how things get done. And that's a big deal, and it's led to a lot of innovation, right? But I'm curious to know your thoughts on the fact that one nice thing about the cloud is that a lot of the best practices for software development have just been baked into it. And what I mean by that is who logged in when, who touched what system when, all that stuff is just baked into the solution itself. So a lot of the metadata that we used to have to manually try to create or build solutions for in the on-prem world, it's all just baked into the cloud, and you can benefit from that right out of the box. What do you think about that, Noam?
Yeah, absolutely. I mean, I think the cloud sort of inherently gives you shared building blocks, right? So for audit or for user management, those kind of things. And then the mode it's deployed, right? i.e. services that you can talk to easily, bring a tremendous amount of sort of baseline consistent functionality. That is what everybody wants, right? It gives you that, single pane of glass on multiple dimensions, whether it's logging, metrics, so on and so forth. And sort of the cloud technologies enable us to all adopt that easily, right? I think, if it was like packaged and fully on-prem and, you're talking about, libraries and configurations and all those kind of things, it's hard to get consistency. But if we all, use the building blocks that work really well, typically provided by the cloud provider or, very big vendors that are establishing standards there, it makes life a lot easier, right? We can sort of focus on the business logic and sort of value add just across the board.
Yeah, that's right. And I'll throw this question over to Titus in the next segment too, but I'll throw it to you, Nong, and just kind of get your take on it, because I'm coming up the learning curve myself to wrap my head around what specifically it means when someone talks to you and says, we want to make this cloud native, our application cloud native. How do you describe what that means from your perspective? What is cloud native and maybe what isn't cloud native?
Interesting. So I think for you to be cloud native, you need to sort of be designed for elasticity and scale. And the application needs to really be able to sort of externalize very clearly and explicitly sort of things that would prevent it from being able to move around, right? So you really understand your dependencies, where state is stored, so on and so forth. So you get that portability and so on and so forth. So I think that is probably the biggest thing I think about when I do that. I think if you get that right, then you can obviously move it around on different infrastructure, different cloud providers, so on and so forth.
We're talking all things cloud today with my guests. I've got Nong Lee from Okira and Titus Kurek from Canonical on the line, dialing in from Poland, a quarter Polish. Happy to have another fellow Pole on the show today. And Titus knows a lot about open source technologies. And we've talked about on many occasions how open source has absolutely revolutionized enterprise computing, the design of applications, the production of applications, the management. I mean, open source is everywhere. It's amazing. When I had my moment, my big aha open source moment is when I was on a plane flying somewhere, and as we're landing, we're just sitting there on the tarmac, and someone in the cockpit was doing, or an IT person was kind of doing a refresh of all the movie screens that you have. And I saw that little penguin sitting there and all the codes flying by. I'm like, look at that. This system runs on Linux. It's open source. So we have a company called Canonical. That's who Titus is with. And they are the purveyors of Ubuntu, which is one of the most popular open source operating systems. And with that, Titus, tell us a bit about yourself and how you can help companies get that single pane of glass for cloud.
Sure. So Titus Kurek here. Thank you very much for inviting us to this podcast. So exactly as you said, I believe most of people know us from Ubuntu. So even if they haven't heard about Canonical, I'm pretty sure they heard about Ubuntu, since it continues to be the most popular Linux distribution all over the world. But our focus is far beyond Ubuntu itself, because we are fully present in the open source space, and we provide commercial services for even big enterprises who are building their infrastructure and running their application on Ubuntu. We provide professional services, commercial support, or even fully managed services for both infrastructure and applications. Exactly as you said at the beginning of the podcast, I think cloud computing market is a very complex market, and when it comes to multi-cloud, there are so many layers that need to be managed properly, so that a need for a single pane of glass is so much important. This is why we make sure that Ubuntu runs with no friction across all of those layers of the multi-cloud.
Yeah, that's really important stuff. And I'd love for you to get into Kubernetes a little bit and to explain it for our audience. And I'll give my explanation, and then you can correct me if I'm wrong. But Kubernetes is an absolutely brilliant project. It's an open source project that came out of Google. And I think what happened is they saw this all coming. Someone was smart enough to see the trajectory of computing in the cloud in particular, but for the enterprise and beyond, quite frankly. And what Kubernetes does, it's this fascinating technology that essentially achieves distributed compute. So it launches containers. Inside that container is some code to go do something. And so when a system or an application needs something done, Kubernetes launches the container, it does its job, and then it just goes away. So they're very ephemeral. So it's a very clever way to distribute compute for very complex environments and for scalability, right? Because if you look at the cloud, and I remember going all the way back to like the late 1990s, so much focus was on being able to scale up, because back then you just had to provision servers for the maximum throughput. And then, like, for example, Black Friday or some holiday season or something, when you're going to get a huge spike in traffic, you used to have to provision for that all the time. So then you got a whole bunch of boxes sitting around on, August 5th when no one is buying anything, and you're paying for all that hardware. Well, that's not a tenable situation. But over the years, and Kubernetes is a big part of this, we can now scale out dramatically upon need and then scale back. But tell us from your perspective, is that about right? Or tell us a bit about Kubernetes.
I think you are totally right. So Kubernetes has definitely, modernized. It has changed the way dramatically of how applications get deployed nowadays. So I think the concept of scaling out came in with cloud computing at all, in general, starting with AWS EC2, right? But then we've quickly realized that with traditional virtual machines, this approach is a little bit ineffective, right? Mm-hmm. Meaning that, and getting back to your point on cloud native, so that applications can now get deployed and they can scale out to answer the needs of increased traffic or increased load. Doing all these kind of things with traditional virtual machines not really effective. So Kubernetes brought this concept of containerization and container orchestration, meaning that applications can now be deployed using much more lightweight underlying, method of running workloads in the cloud. That was super effective and worked super well with the scale-out approach that was first introduced by the cloud computing concepts, right? And if you think about Kubernetes itself, actually, it's another example of a single pane of glass, because it quickly gives you an overview of all of your containers that are running under this particular infrastructure, meaning that it can be used to, spin up new applications, scale them out as the needs for that increases, scale them back, decommission, and monitor the current situation and the current status.
Yeah, and that's a big deal. And it just fascinates me how that engine works. And so someone finally described it to me, and I kind of got it better than I had before. She said, think of it as little system processes, just the little things that your operating system will do when you're launching an application or using an application. The app is reaching into the operating system to get little bits and pieces of functionality to do what it needs to do, what you ask it to do. And what Kubernetes did is it basically created an engine for dynamically provisioning those little bits of processes that are needed by the applications to get things done. And so in doing that, it has a much lighter weight footprint and is easier on the operating system as well, it seems to me. So it allows you to scale out in a very durable and efficient way without overtaxing the OS at any given time, right? Because a lot of times when systems are down or systems crash, it's either because the CPU overheated or something else really bad happened in the environment. But if you have a distributed fabric of compute underneath, then one CPU crashing isn't that big of a problem anymore. You avoid that so-called single point of failure. What do you think about that, Titus?
I think you're absolutely right. So if you have a look at how traditional virtualization technologies used to work, the approach was to basically emulate the entire operating system, including the underlying hardware that was now represented in the form of a virtual hardware resources that would cover the kernel of the operating system that was basically present inside of traditional virtual machines as well. And that would cover all applications that would be running on top of the operating system. So the Kubernetes and the containerization technologies entirely changed that, meaning that they got rid of all of the virtual hardware layer, and as a result of that, there was need for a kernel to be present in the workload anymore, meaning that all you actually run inside of containers are just the applications. The first iteration of Linux containers, that's called LXD, was allowing to run multiple processes inside of a single container, basically meaning that you could think of the workload as a kind of a separated environment under the operating system with a set of applications running there. While Kubernetes went one step ahead, basically launching a single process inside of a container, meaning that applications can be provisioned really effectively, very quickly, and they can scale out almost immediately.
That's so interesting. And what I think about where virtualization came from, and it was designed to optimize the resource of the box, right? So you would virtualize access to the box, and because what you'd have is compute would be very low most of the day, and then it would spike up when things are done. And with virtualization, the idea was to really make that a much more efficient process overall. So you're trying to optimize the value of your existing infrastructure. And then what Kubernetes did is it just did the same thing in a different way, right? And so to your point, to just throw a bunch of VMs up into the cloud, yeah, it can work that way. But when push comes to shove, it's always about performance, right? That's the key, is you have to perform at speed, at scale. You have to perform as well as you need to in order to get the business, to keep the business. And in a web-enabled world, people don't want to wait because they know that this site goes real fast. And if your site doesn't go real fast, they're not going to spend much time on your site. And if the functionality isn't good, you're going to lose that business. I think that Amazon, for example, has done a fantastic job of creating this bulletproof infrastructure. I will say that and I've used some of these technologies myself for Amazon for like selling products and things. And, it's not a very intuitive environment. I mean, you better read a lot of instructions and pay close attention to what goes where, but they are giving you access to this incredibly robust infrastructure that is borderline bulletproof, right? What do you think about all that?
Correct. So indeed, virtualization, as you said, was kind of invented to help organizations bypass the scalability limitations of the underlying infrastructure, right? If you think about the server and its compute, network, and storage resources, they are limited, right? You can always buy another server that has more CPUs and has more RAM installed in there or more storage, but at the end of the day, like you're limited by the hardware constraints. So meaning that if you want to have isolated workloads running on a single server, the approach was to partition those underlying resources and allocate chunks of them to virtual machines. That was again kind of causing some scalability limitations because you couldn't partition, that you can partition into some chunks, but not into hundreds of them, for example, right? With the containerization layer running on top, those resources are actually shared rather than partitioned, meaning that the resources can be used much more effectively. So that was one of the advantages of containerization and what Kubernetes brought to the market as well.
Yeah, right. No, it's amazing stuff. And we mentioned before about wanting to be able to leverage these different environments. And I think what's happening is a lot of organizations, they're using, let's say, Workday, and they've used it in a particular environment. They're using some other technology that's already there in Azure. They're using a technology that's in GCP. So being able to stitch together processes across that environment, that's where things get a little bit tricky, I would tend to think. But just for my edification, would Kubernetes run efficiently in an environment like that? Like, could you deploy it on-prem and then have it spinning out containers to different cloud environments, or is that too frail?
This is where it becomes really interesting, because this is what most of the organizations nowadays are trying to do. So we're no longer living in a world where people are running their workloads in a single cloud. Most of our customers, for example, actually use multiple cloud providers and multiple substrates at the same time, right? This is coming from various things. So either they went to public clouds first, and then over time they realized that the costs continue to grow, so they started migrating back to an on-prem infrastructure, or they're running their workloads in various public cloud providers because this helps them to negotiate better prices, or simply particular features or workloads are not supported if they run it on a single cloud. So this hybrid multi-cloud environment and hybrid multi-cloud setup with some workloads running on-prem and some running in public clouds is really emerging, and we see more and more organizations actually going with this kind of a setup, even though it poses those challenges again, like how are you going to manage this distributed environment and those various types of substrate, right?
That's right. But I like the point you made about how Kubernetes itself is like its own single pane of glass, because you can see all the different containers that are running. That's just fascinating, because now it's almost like watching the vehicles in a train yard or the cars in a train yard move around. Those are the containers. They contain little bits of functionality to get stuff done. And the key is to enable that scale out, that immediate scale out that will not have any detrimental impact, or at least nothing significant on your business. It's very cool stuff.